This lesson is on angle properties. So when we're looking at this geometric figure here, we have an isosceles trapezoid. What an isosceles trapezoid is it's a trapezoid, which means we have a set of parallel sides. And isosceles means that these two sides here would be equal in length. Okay, so two sides are the same length. QR here it says is parallel to TS, and I can denote that with a little arrow on this one and a little arrow on that one. An angle QTR, this angle measures 22. QRT is this angle here, and that one's 15. And we're trying to find the measure of angle TRS, so make sure you know which angle it is first. T to R to S. So that would be this big angle right here. So first thing I'm going to do is I am going to try to figure out what this angle is. And how I can do that is by taking this triangle here, because I already know two of the angles in this triangle. And you should know that a triangle, the angles add up to 180. So if we take 180 minus the 22 minus that 15, we get 143 for this. And if this whole angle is 143, and this is an isosceles trapezoid, an isosceles trapezoid has a special property where these top two angles are going to be equivalent to each other. So if this one's 143, that would mean that this entire angle from here to here is also 143. But we only want part of that, this part here. So if I take this 15 plus the blue piece, it would give me that big green piece, and the big green piece is the 143. So what we're going to do is we're going to take the 143 and we subtract that 15 piece from it, and that's going to give me what's left for that blue piece. So 128 degrees. Okay, then moving over here, we're still going to use the same thing with the triangle adding up to 180. You'll probably see that on the ACT. The other thing that's used in this one is called a straight angle. So this piece here is 123. And then this piece here we can find because this entire half of a circle should be 180 degrees. So all you have to do, that's called supplementary when they add up to 180, is you take 180 and you subtract 123, and that leaves us with this little sliver in here being 57. So I'm going to redraw this triangle right here so that it's larger and a little more exaggerated. That way I can actually fit my pieces in here. Okay, so this piece over here was 123, which left this piece in here being 57. And then same idea on this side. If I know that this angle out here is 67, and this whole thing is a half a circle, so it should be 180 degrees, I take 180 and I subtract 67, and it gives me 113 here. And they're telling us to try to find what this angle is. These three angles should add up to 180. So if I add these two pieces up, I get 170, so this has got to be 10 degrees to get me to 180. Alright, then moving down to the bottom. Now this one doesn't have a picture, so sometimes that makes it more difficult for people, but it gives us a triangle. So whenever it gives me a triangle, I don't typically worry too much about drawing it perfectly to scale. I just draw a triangle. And it says, it calls it triangle ABC. So let's go ahead and label A, B, and C here. Angle B measures exactly 89 degrees, and angle C measures greater than 25. So this is greater than 25. Which of the following best describes the measure of angle A? So if this is bigger than 25 and this one's 89, that means together they're going to add up to more than these two values added together. So together these are going to add up to 114 more than that, because this one's greater than 25. And these three angles should add up to 180. So if I do 180 minus the 114, that gives me 66 if this one was 25. So if that was 25, this one would be 66. But if this is greater than 25, if I move that up to a bigger value, this one's actually going to move down to a smaller value because they have to add up to 180. So if this was 26, this one would only be 65. It would actually shift down. So what do we know about A? It has to be less than 66, which would be A.